Hi, good morning, everybody. My name is Darren Kimura. I'm the CEO of Sopogy, Solar Power Technology. I've got 6 minutes to present our company story with you today, and my remarks are prepared as such. After the presentation, I'll be apparently out front for about half an hour, so if you want to learn more about Sopogy, please feel free to visit with us then. Sopogy is primarily focused on, I guess if you could focus on this screen here, really 4 things. We're, unlike some of the companies that were up here previously, we're focused on a customer-sided solution for commercial, industrial, and small utilities. We deliver pre-packaged solutions, which is the solar collector, as well as some of the devices like the turbine that can create the power in a template solution. We design our system to be installed very quickly. So rather than 8 years that the large solar farm might require, we're talking about 8 months for installation. And we are primarily focused on giving our customers the fastest payback we possibly can achieve. So our technology is modeled very similarly after the traditional parabolic trough technologies, very much known, I think, by this audience. Parabolic troughs, for the most part, were designed for desert applications. That's arid conditions, very minimal weather type environment situations, and they're very big. You can get a sense of scale here. That's a person 6 foot tall next to a solar collector parabolic trough. What we did at Sopogy was we took the premise behind the large-scale parabolic trough and we shrunk it down. We went after a more modular approach for manufacturing through a high-speed precision process that allowed us to be able to flat pack and flat ship our technology. That means we're not shipping any dead air between project sites. We've designed the technology to also be a lot smaller than the traditional solar collector, thereby allowing us to have more reasonably installed smaller scale installations that could even be put on rooftops. So here you get a good sense of scale and size. That's a 6 foot person next to our, what we call micro CSP technology. Of course, to make a system work, you take a series of collectors together and we can scale that up to do a variety of different things. The markets we're looking at, we're not looking to compete with PV. We're not looking to install the technology on a home, nor are we looking for 1,000-acre deployments in the desert. We're looking to satisfy the middle markets. That would be your industrial, your large-scale commercial, even your small-scale utility, 1 megawatt to 20 megawatts. So really looking to fulfill that middle gap. Again, really our key markets are large commercial, industrial, and small-scale utility. Because our technology is smaller in size, we can achieve effective storage via a different approach than the large-scale parabolic or concentrating tower systems do. We actually use thermal energy storage in the form of hot water. So rather than going with molten salt storage or hot wax or some of these exotic type materials that you hear of nowadays, we actually use a very traditional form, very similar to the hot water storage that might be used in your home. That's exactly what we do. That enables us to do really 2 things with our technology. One is to have solar buffering, which means if there's a cloud that comes in, sometimes you're going to find that PV can be intermittent. If a cloud comes in with our buffering system, we can ride through that. The second thing we're able to do is actually extend the solar day. That gives our customers more production hours. Production hours at the end of the day for them means more energy generated, which means more cost savings, which translates into a faster payback. Because our technology is smaller than the traditional parabolic troughs and we're not doing PV, we're not necessarily going electron directly, what we primarily focus on is what we call process heat. So same premise, we use our reflectors to focus the energy of the sun into a receiver tube where we circulate a mineral oil. We make that mineral oil as hot as we possibly can. Through that working heat, you can do a variety of different things. In one case, you can do power generation via a turbine, where our efficiencies are at about 20%. That gives us about an 8-year payback for our customers. But in addition to that, the more higher efficiency avenue is directly using the process heat for industrial applications. That's about a 60% efficient type approach. Payback of about 5 years. And then, of course, something we all know about, absorption air conditioning or thermal air conditioning, connecting up our heat next to an absorber unit, which gives us cold air. Again, a little bit lower in efficiency than process heat, but slightly higher than electrical energy, 25% efficiency. So in summary, and again, I've only got 6 minutes here, I want to leave you with the following analogy. We look at micro CSP being very similar in characteristic to the compact fluorescent lamp. When the CFL first came out, this is back in the early 90s, the predecessor technology was a very large and fat fluorescent lamp. When the technology CFL first came out, there were a lot of first generation challenges, a lot of out-of-the-box failures, but the technology had incredibly disruptive promise. The technology and the industry began to evolve and got more efficient. Cost prices became more in line with what consumers were expecting. And as a result, today we have a national standard that mandates a compact fluorescent lamp. Micro CSP, the space we're specifically focusing on, has very similar characteristics. One, our predecessor technology is based upon the very large parabolic trough technology that's been around for over 30 years, operating very effectively and financeable. We've got first generation technology challenges, of course, but we're getting there. The energy savings, again, extremely disruptive, up to 50%, possibly more for our end user. And one day, who knows what the potential could be for micro CSP. So please visit us at sopogy.com. And of course, I'll be out front for the next half an hour or so. Thank you very much.